Hello everyone. Today we are going to see the solution of the problem where will the ball fall. So in this problem we are given a 2D grid of size m cross n representing a box, and we have n balls. So the box is open at top and the bottom sides. So suppose this is the box and the box is open at the top and the bottom. Now each cell in the box has a diagonal board spanning two corners of the cell that can redirect a ball to the right or to the left. So we can see that each cell will contain a diagonal which would redirect a ball to either right or either left. So we can see that this diagonal will redirect the ball to the right, while this diagonal will redirect the ball to the left. So if the value of that cell is 1, then that diagonal will redirect the ball to the right. Similarly, if that cell is -1, then that diagonal will redirect the ball to left. Now what we do is we drop one ball at each column, the top of each column of the box. Each ball can get stuck in the box or fall out at the bottom. A ball gets stuck if it hits a V-shaped button between the two boards, or if board redirects the ball into either wall of the box. So we can see that suppose we drop a ball here B0. So because it directs the ball to the right, it goes right, 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 down, right, down, and it comes off the at the bottom. So it comes out of the column 1. Now similarly, if we drop ball at B2, suppose we drop ball at B2, then we can see that the ball will get stuck because now V is forming here. So ball will get stuck. Similarly, here also the ball will get stuck. Here also the ball will get stuck. So wherever we can see that V is formed, then ball will get stuck. Similarly, we can see that here also the ball will get stuck because it is pointing to the left. The diagonal is pointing the ball to the left, and there's a wall here, so ball cannot go anywhere else. So uh, here also we can see that it is not forming exactly a V, but ball will get stuck here. So let's see the constraints. So the constraint are m and r less than or equal to 100. So we can see that m into n will be accepted, m into n into n will be accepted. Basically m square n and mn square can also be accepted. So we can make some quick observations from here. So suppose we have this as our box. We can see that the so we have already seen that a board that redirects the ball to right spans the top left corner and the bottom right corner and is represented as 1. So the value of this cell will be 1. Similarly, the value of this cell will be 1. This will be -1. This will be 1. This will be 1. This will be 1. This will be -1. This will be -1. This will be 1, 1, -1, -1. So we can see that wherever 1 and -1 happens, then V is formed. Similarly, wherever suppose this is a diagonal, suppose wherever -1 is happening and the it is at the left corner of the box, here also ball will get stuck. Similarly, suppose this is the right border of the box, wherever there is 1 here and to the right the box ends, then here also ball will get stuck. So this is the main observation. Now what we can do is, for each column we will drop the ball. So we will drop B0, B1, B2, B3, B4 at these columns respectively. So we will simulate for each column. Suppose we drop ball at column 0, then we can see that at that cell there is 1 and to the right it is 1. So there will be no problem. The ball will go to the diagonal down right. So basically, suppose the x coordinate will be the x and y here will be 0, 0. Now we will drop the ball. So x will be increased by 1 and y will be increased by 1. So the ball will go here. Similarly, it will repeat. The value of this cell is 1 and the value of the cell to right is also 1. So x plus equal to 1, y plus equal to 1. Now we can see that the value equal to -1. So we will check that if that value is -1 and the value to the left cell is also -1, then x will increase by 1. Basically the row will increase by 1 and the column will decrease by 1. So the ball will come here. Now we can see that the cell is 1 and the cell to the right is also 1. Then x plus equal to 1, y plus equal to 1. Similarly, x plus equal to 1, y minus equal to 1. Now the column is 1 and we can see that ball comes out of the first column. So we can take now example where the ball gets stuck. So suppose we draw ball b1. Now value is equal to 1 here and the value to the right is also equal to 1. So x plus equal to 1, basically the row plus equal to 1 and column plus equal to 1, it will come here. Now we can see that the cell is 1 here and cell to right is minus 1, then answer will be minus 1. So just break out and enter minus 1 in the answer of first column. So we can see the code here. First find out the size of the grid, then initialize the answer array. Now we will simulate for each column. So initially row will be 0 and y will be equal to the column. Now OK is the flag indicating if the answer exists or not. We make a while loop. If we came out of the box, then break. Now make two cases, if cell is 1 or minus 1. So if cell is equal to 1, then we will see that if it is at the right border or the cell to the right is minus 1, then it will get stuck and we will make the flag 0 and break out. Else increase x by 1 and increase y by 1. Similarly, if grid is basically the value at that cell is minus 1, then it is pointed to left. So if it is at left corner or the set to the left is 1, then we will break out and make OK equal to 0. So no answer will exist for this column. Basically the ball will get stuck and x plus equal, if not, then x plus equal to 1 and y minus equal to 1. Now after breaking out of this loop, if flag is 1 means that answer exists, then we will append the y in answer, else answer will appended by minus 1, then we will return the answer. So let us submit. You can see that the code is accepted.